Hello my friends, welcome back. In this week's video, we're going to learn the concepts of the cosine rule, and then I'll be providing you some examples in the video. Now this is a complete lessons on the concepts of the cosine rule, so do stay to the end, and I'm confident that at the end of the video, you will be very proficient in applying the concepts of the cosine rule. Right, so some of you may be wondering, why do we need to learn the cosine rule? Haven't the sine rule sufficient to find sides and angles of a triangle? Alright, let's do a recap on when we can actually use the sine rule. Right, if you're given a triangle and if you're given two angles and a side, then you can use the sine rule as demonstrated on the screen. Right, you can also find this angle, which is just 180 minus away this and this, right? So in this situation, you can actually use the sine rule. Let's look at another situation where you can actually apply the sine rule. That is when you're given two sides and a non-included angles. Right. So, but there are certain cases where this is not the case. These are not the cases. Right. So what are those? Yes, it is when, for example, you're given two sides and an included angle. So in this situation, let's see how we can actually apply the sine rule, right? If I'm going to label this angle as A, the sides opposite angle A will be lowercase a. I'm going to label this as B. This will be lowercase b. This is C, and this is lowercase c. Let's see what happened. So I'm given sine A, so that's sine A over A equals to, okay, any of the angles will do. I'm just going to write down. Alright, so supposing I concentrate on this, let's see what are the informations that you're given. So you're given A, right? So that is given. The one that's given, I put a tick there. And then you're not given the sides A, so this is not given, so put a cross there. This is not given, and this is given. Right, so can you see that there are actually two unknowns? There are two unknowns there in an equation. So how is it possible to solve equations with two unknowns? Usually when you have two unknowns, you should have two equations and you solve it simultaneously, right? Right, so therefore in this situation, you cannot apply the sine rule. So let's look at the other equation. Okay, so if you look at this, right, sine B is not given, angle C is not given, and the side C is also not given. Cross, cross. Not given means cross. Right, so this is even a worse situation than the earlier on. If you're only given one known data, which is side B. Right, so in this kind of situation, you cannot apply the sine rule at all. And that is the reason why we have to learn the cosine rule. So can you think of any other examples that you can't apply the sine rule? So we will do that. We'll do that in the next few slides. So please stay on. Right. So in this slide, I'm going to show you how to derive the cosine rule. But if you're one of those that's not interested in the derivations, and if you just want to know how to apply the cosine rule, then you can just skip these two slides. Okay. So this slide is we're going to prove we're going to derive the cosine rule when the angle ACB is acute. Okay, so first thing first, we're going to just label all the angles, with the uppercase and then sides with the lowercase. Okay, we've done this quite a lot of times already, and I trust that you're able to do it proficiently. All right, so I've just drawn a right angle triangle there. So a right angle triangle will link you to concepts like Pythagoras theorem, to concepts like Tuakaso, the trigo ratio. Okay, I'm going to call the perpendicular height h. Yes, and then C to B, I'm going to divide it into two parts. the one highlighted in green, I'm going to call it x. And the one highlighted in yellow, it will be a minus x. Why is it a minus x? Because the length CB is a. The length CB is a. So therefore, the one in yellow will be a minus x. So we're going to focus on the pink triangle, and we're going to use the trigo ratio on the pink triangle. Oh, Pythagoras theorem. Sorry, I made a mistake. We're going to use Pythagoras theorem first. Yes, there's no angle given. So we're going to use Pythagoras. Oh, the angle is actually angle C. Okay, never mind. We're going to use Pythagoras theorem. So that will be b squared equals to x squared plus h squared. We're going to call it equation 1. And then we're going to focus on the blue triangle. And this time here, we're also using Pythagoras theorem, which will be c squared equals to h squared plus bracket a minus x close bracket squared. Right, and this thing we're going to expand it. So if you have forgotten how to expand it, okay, let's do a recap. This is your algebraic identities. All right. And what do you think is the next step? Yes, we're going to simplify it. You're just going to group your x squared and h squared, a squared together, and minus 2ax squared equation 2. Right, and then you'll be able to see that this one here, right? Can you see a connection there? So what do you think I can do with the two terms that I've squared it? Square it, no, sorry. I box it up. Yes, I can actually substitute equation 1 into 2, and let's see what happened. Right, and we end up getting c squared equals to b squared plus a squared minus 2ax. Okay, now what happened is that I still need to get rid of my x. Why is that so? Because the cosine rule, the formula for cosine rule will just involve c squared, a squared, c squared, a squared, b squared. There shouldn't be any x or h there. Right, so how do I find x in terms of a, b, and c? That is when I have to use the pink triangle again, and that is when I need to apply the trigo ratio. Here I'm going to use cosine. So cosine it's CAH, C-A-H, adjacent over hypo. Adjacent it's x. Your hypo is b. So you do a cross multiply, x is equals to b cos c. So from there I can actually substitute equation 4 into 3 to get our cosine rule. Okay, so this is the cosine rule for you to find the unknown side c. You start off with c squared. You start off with c squared means you're going to find the unknown side c. So can you make a guess? If I want to find the unknown side a, how do you think the formula will look like? Or if I want to find the unknown side b, how do you think the formulas will look like? Based on what we have just found here. So think about it. Alright, so if you're just happy deriving the formula when angle ACB is acute, and you're not interested when the angle ACB is obtuse, the formula we've just derived, it's able to solve whether acute or obtuse triangle. Okay, but for some of you who are interested to know, right, so please stay on with the slides. So now what we're going to do is what happened when the angle ACB is an obtuse angle. So we have a triangle with obtuse angle ACB. So the way we do it is slightly different from what we have done earlier on. Okay, see, because the right angle triangle is going to be an extension to the triangle ACB. Okay, this is what I mean. All right. Okay, and we're going to call let the blue colored line be h, the perpendicular height, the yellow one be x. And as usual, we're just going to label all these sides. Okay, right. So for the right angle triangle, of course, we're going to use Pythagoras theorem. We're going to use trigo ratio. So let's see how we do it. Okay, we're going to call that point D. So it's easier to reference to it later on. So in triangle ADC, okay, in the triangle ADC, the small right angle triangle, okay, cosine bracket 180 minus C will be adjacent over hypo, which is DC over ACE, which is X over B. Yes, so this is something very important, okay. This is what we have learned earlier on in the earlier video. I have one that explained how you find trigo ratio of an obtuse angle. You can actually refer to it. You have forgotten this concept. So therefore, cosine bracket 180 minus C, you can just write it as negative cosine C. All right, and then you make X the subject. Just multiply by B on both sides. So you end up getting negative B cosine C. All right, so this is equation 1. Now the next thing we're going to use triangle ADC. Oh, the same triangle again? Yes, to use Pythagoras theorem. Okay, in triangle ADB now. Alright, so you see that we're actually using all right angle triangle because only a right angle triangle then can allow us to use the Pythagoras theorem or the trigo ratio. Okay, so that's the reason why I need to extend a right angle triangle out of your obtuse triangle ACB. So in the triangle ADB, the bigger guy, okay, using Pythagoras theorem, the h squared plus, okay, plus db. So db will comprise of x plus a. So you square it equals to c squared. And here what we have done is, again, we expand it using the algebraic identity, gives you x squared plus 2ax plus a squared equals to c squared. Okay, right. So notice something here. Notice that this one and this, yes, okay, they are the same, right? So you can equate 2 equals to 1, or you substitute 2 equals to 3. And also substitute your equation 1 because you need to replace. Can you see you have an x here? You need to replace your x. Okay, so you substitute equation 1, 2 into equation 3. And that's how you also get the cosine rule formula, right? Which is the same as what we have derived earlier on when the angle ACB is acute. Okay, right. So the next slide will be the application part. So please don't miss it. Alright, so let's look at an example. Supposing I have a triangle, obtuse angle triangle. Let's label all the sides properly. Some students, they may think that, oh, it's not important to do all this labeling, but my advice to you folks is that if you're first time applying any rule or any rule, okay, please do it diligently. Okay, don't think it's a hassle. Do it diligently. After you master it already, then you can just what do you call that, skip all these steps. Okay, right. So I'm going to find the highlighted side. The highlighted is the one highlighted in yellow. So the formula will be a squared, start off with a squared, and then b squared, which is the one highlighted in green, plus c squared, the one highlighted in green also. I should have used a different color. So minus, there's a 2 there, times b times c, and cosine angle A. Okay, right. So what happens if I want to find the side A instead of the side C? Side B, sorry, what happened? I've already done with A. What am I talking? What happened if I want to find side B? See, the side B is the one highlighted in pink, right? So you start off with B squared equals to A squared plus C squared. Oh, this is really very slow motion. C squared. Can sleep, can fall asleep. Okay, cosine B, uppercase B. Yep. Okay, so what happened if you want to find C squared instead? All right. Oh, I leave it for you. I leave it for you to think about it. Okay, that's very evil, but it's easy. Okay, it's easy. Just see the relationship. You see, if you start with a squared, of course the next thing will be just b squared and c squared, right? Because ABC are the sides of the triangle, right? And then this angle here is always the angle that's opposite the sides. You see, so it's pretty easy to come up with the formula to find c squared. Yes, it's just c squared equals to a squared plus b squared minus 2ab cosine c. All right. Okay. Okay, so once we have all this, all these concepts of how to apply the cosine rule, let's put it into practice. So let's look at one example. Right, so if you're given the triangle PQR, okay, you're given the length PQ is 10.8. It's very important to read questions carefully, okay? QR is 15.9, PQR is given to be 71. Find the length of PR. Okay, what's the first thing first we need to do? Yes, first thing first is to label all the sides, okay, with all the okay, label all the sides. Right, and then the next thing is just we're going to find c squared, right? Find c squared because we're going to find PR. So that will be c squared equals to pink color. We're going to find the length that's highlighted in pink. Okay, then what does c represent? Okay, usually I would advise the students to write down the formula first, and then the next thing is to fill in what you're supposed to find. Fill in the correct label. Alright, so in this case here for part 1, what represents C is your length PR. So replace the letter C with PR. So that will be PR squared. And A squared is 15.9 squared plus B is 10.8 minus 2 times 15.9 times 10.8 times cosine 71. Your angle C is this guy here. I forgot to label it. That is your angle C. Okay, so this whole chunk of thing, you can just easily use a calculator to work this out. Okay, please don't go and work out parts by parts. All right, it's you have a lot to write. If you're going to work parts by parts, then you need to write this plus this minus, you know, so many things to write. So the easiest, shortest way is to just key all this thing into your calculator. Key all this thing, it will just give you a value. Okay, but you have to be very careful when you key inside your calculator. Make sure you do it correctly. Oh, yeah. Okay, so I'm being very what they call that, systematic. I just want to show you that the side C is opposite the angle C, which is 71 degrees. See how good I am? Okay, never mind. So we work out the values to be 257.637. Okay, and that we're not done yet because you're supposed to find PR and not PR squared. So we need to square root that value, and that gives you 16.1 centimeter. And then if you have been following my video, you will realize that I always have an in-between answer. This thing is called the in-between answer because usually this in-between answer will be needed to solve some other parts. Okay, and so for more accurate answer, for more accurate final answer, because your final answer should be 3 significant figure for non-angles. It's 3 significant figure, right? Usually you should have one which is about 4 or 5 significant figure. Okay, so it should have 2 answers, 1 to 4 or 5 significant figure, and then the final one is 3 SFF. Okay. Alright, so for part 2, we're supposed to find angle QPR. Angle QPR, so it will be this angle here. Okay, the funny things about us folks is that, you know, usually after learning a new concept, right, we tend to just keep using the new concepts and then to forget about the old concepts. But you must remember that the sine rule and the cosine rule, yeah, they're actually BFF, the best friend forever. So sometimes if you cannot use the cosine rule, you still have to rely on your best friend, which is the sine rule. So please don't just forget about sine rule, okay? Right. Don't just make new friends and forget about the old friends, okay? Old friends are equally important in your life. So in this case here for part 2, okay, we need to apply the sine rule. So first thing first, we already found the values for PR, right? So we just plug it in. Okay, look at the values that I use for PR. Can you see that I actually use one that is 5 significant figure and not 16.1 as explained earlier on, okay? Right. Right, so we're going to label the angle A. Okay, do all the proper labeling. Yes, don't forget the sine rule. Here we have to apply sine rule. Okay, so we're going to use sine A over A equals to sine B over B, and then plug in the actual labels for sine A, which is angle QPR. Okay, if you've forgotten how to do sine rule, refer to my earlier video. The next step is to do a cross multiply. Okay, we just take this guy times this, and then the equal sign is always in the middle, equals to, we always go this direction first. We always do the directions where the unknown, so your unknown is angle QPR. So you start off with the unknown. Okay, so the unknown times 16.051 gives you the other one, and then you divide both sides by 16.051. Okay, you will get 0.9366, and then you sine inverse it. Right, so you see again that I have one value, that is more than 2 decimal places, because I will need to use it in part 3. But my final answer for angle is always 1 decimal place. Okay, right, so we have found the angle QPR. So that's plug in the value. Correct. So the next questions that I need to ask you is that you have already found QPR to be 69.488, and you know PQR is 71. Do you still need to use a sine rule to find angle PRQ? Is it necessary? The answer is a bit no. Why? Yes, because you can just simply use 180, which is the sum of angles in the triangle, minus away 69.488 minus 71, and you'll get PRQ to be 39.5. But of course, if you have a lot of times, plenty of times, and you're so bored and the paper is so damn easy and nothing to do, you can still go ahead to use the sine rule to verify that PRQ is 39.5. Okay, so please bear with it because this is the second last slide. Yes, and I'm sure you are very close to being a proficient, okay, a proficient, what do you call that? User of the cosine rule. So in this question here, you're asked to find the angle, the side of the largest angle. So if given the triangle PQR, okay, PQ is 13, QR is 18, PR is 11. So we need to decide which angle is the largest angle. And then if you have not missed the video on sine rule, which I really hope you go and look at it. I spent a lot of time doing it, and I think I'm quite proud of my explanation. But of course, it's important for you to understand now. Understand my explanation. There's no point that I explain until so clearly and nobody understand. What are you talking? Okay, right. Anyway, so in the earliest video slide, right, I explained that the largest angle is the one that's opposite the which side is that? Yes, the longer side. And if you look at this diagram here, which is the longer side? Yeah, you come out too late. I've already explained it. Yes, the longer side is your 18 centimeter. And therefore, the angle we have to find is the one that's opposite it, right? Which is your angle QPR. Okay, right. So first thing first, what's first thing first? Yes, correct. Let's label all the sides. Okay, label all the sides and with label all the ABC. Please don't miss out these steps. Okay, right. It's important. Okay, write down the formula. Okay, and then fill in all the unknowns. So side C is 18 squared, C squared is 18 squared, A it's 13, so 13 squared, B it's 11, as indicated on the diagram there. So 11 squared minus 2 times 13 times 11 times cosine. Okay, so this part here is a bit tricky. You have to be very careful. This one, okay, you can't use your calculator to pop all the way. Okay, you cannot, because there's an unknown here. All right. So the danger of this is that I have to warn you folks, please, you can't use a calculator to throughout. Okay, the common mistake made by some of you guys is use calculator 13 squared plus 11 squared minus 2 times 13 times 11, and then you come up with something cosine angle QPR. Okay, this is wrong, wrong. Okay, so what is the correct way of doing it? The correct way is we can simplify, we can use a calculator to work out 18 squared first. We can use a calculator to work out 13 squared plus 11 squared. We can use a calculator to work out 2 times 13 times 11 only. You see the slow motion there? The slow motion is for you to pause and think. Yes, work this out using the calculator. And your cosine QPR is there, times cosine. Okay, so this is the correct way of doing it, all right? Please, if you've forgotten what I've just said earlier on, please rewind. Okay, now the next thing is that, yes, I can. Okay, usually I would advise the students to do this way. Since you are finding cosine angle QPR, right, put this on the left hand side. Okay, just change position only lah. Put it on the left. 3, 2, 4, put it on the right. And minus, the next thing is that minus 290 on both sides. Okay, minus 290. Yeah, and use your calculator to work this guy out to be 34. And then the next thing is divide both sides by negative 286. Okay, and then you cosine inverse it. And you get 96.8. Okay, so that is your largest angle. Wow. Okay, that's it. Alright, so this is the last slide. And this slide will actually determine if you have if you're proficient or not. Okay, so if you are able to solve these questions, alright, I've already provided the answer for you. Part 1, find the area of PQR. If you've forgotten the formula to find the area of PQR, do refer to the earlier videos. Otherwise, I can just give you a hint. It's area of a triangle. You can use half AB sine C, half AC sine B, half BC sine A. Okay, right. And then part 2, you have to use your cosine rule. Find the total length of the rope using to form triangle PQR. So basically, you just need to find this side here using cosine rule, and then you add all the 3 sides together. You should get 20.5. And if you don't get the answer, you can just private message me. All right. Okay. Thank you very much.